couple of weeks ago, I posted a video which talked about the Big Bang Theory and the steady state theory, which you can check out here or in the description. In that video, I mentioned the CMBR, or Cosmic Microwave Background Radiation, which I stated was the electromagnetic radiation that came around 400,000 years after the Big Bang. It was crucial in disproving the steady state theory and crucial in proving the Big Bang Theory. I couldn't go too in depth into what the CMBR actually was, as I was running out of time in the video, but now I'm making a complete, detailed video about it. To start off, we need to understand what a light year is. A light year is the distance that light travels in 1 year, when it moves continuously. Light is the fastest thing in the universe, and a light year is commonly called the speed limit of the universe. It travels at around 300,000 kilometers per second, which means that it can travel around the Earth 7.5 times per second. Now, as of right now, light may seem like this infinitely fast thing that can get you to any place in seconds, but that is not entirely true. Compared to the immense scale of the universe, light actually takes a really long time to get to places. For example, it takes light 1.3 seconds to reach the moon from Earth, 8 minutes and 20 seconds to reach the sun, and 4 years to reach the closest star to the sun. And for some perspective, our galaxy is around 100,000 light years across. Another thing about light is the fact that we need it to look at something. If there's no light being reflected or emitted by an object, there's no way of seeing it. This fact, paired with the fact that light takes time to get to places, means that we can essentially look in the past. That may sound like I'm full of nonsense, but it is true. Let's use the CMBR as an example. The light that first got emitted by the CMBR around 13.8 billion years ago started traveling through space. It traveled for billions of years and eventually landed on Earth. That light started traveling just a couple 100,000 years after the Big Bang and landed on Earth around 13.8 billion years later and was captured by the Bell Labs Holmdel Horn antenna. This means that we are looking at something that was formed around 13.8 billion years ago. This is what I mean by us looking into the past. Now that we know how we discovered the CMBR, let's focus on what it really is, the essence of it. As I mentioned earlier, it is electromagnetic radiation that formed in the early stages of the universe. I'm sure you've observed the blue, yellow, and red spots in this image. The red and yellow light represents areas that are slightly warmer, and when I say slightly warmer, I mean fractions of degrees warmer. These spots are what have evolved to form the ironically darkest areas of the universe, areas with no galaxies, or in other words, cosmic voids. The darker areas of the CMBR, so the blue regions, are the slightly cooler ones and are more dense in matter than the lighter ones. This means that it would eventually form the galaxies, stars, and planets that we see today. If you do have any comments or questions, feel free to put them down in the comment section, and if you want to learn more about science or maths, subscribe for more.